Hi children, welcome to my channel Excellent Tutorials. Today I am continuing the passing package for the 10th student. Now I am doing prove that the following numbers are irrational numbers. Okay, first we'll start. First sum 2 minus root 2 is irrational number. We have to prove the given number is 2 minus root 2, that is irrational number. Okay. First, let us assume that 2 minus root 2 is rational number. That means that is equal to 2 minus root 2 is equal to a by b. Rational number means in the form of a by b. A and b are integers. B is not equal to 0. Or a, b are co-primes. Okay. Root is equal to 2 minus a by b. I have to transfer this 2 to right side. This minus root 2 take one side and 2 take towards a by b. Okay. Because we have to keep only one root number, irrational number, one side, remaining every part we have to take to other side. Okay. Now simplify this. 2 minus a by b. By simplifying this, we'll get, to simplify we have to take this b as a denominator, as a LCM. Then I have to cross multiply b into 2b minus a as it is. 2b minus a by b, that is equal to root 2. This equation says this is a rational number. Since a and b are integers, therefore this root 2 is also becomes rational. Right side is a rational. A, b are integers. Then this fraction is called as rational number. If it is rational, then left side is also rational. Root 2 is also rational. But we know that shortly we can write WKT. We know that root 2 is not rational. From previous class only we studied that root 2, root 3, such numbers are not a rational number. By our knowledge, we know that root 2 is not a rational. This leads to contradiction. Because here we proved that this is a rational. According to this equation, root 2 is a rational. But we know that it is not a rational. We are saying 2 also. It is rational, like that we proved. But root 2 is not a rational. That we know by our previous knowledge. We are saying 2 way also. That means that leads to contradiction. Therefore, our assumption is wrong. What we assumed in starting, 2 minus root 2 is rational number. That became wrong because that leads to contradiction. That's why that given number 2 minus root 2 is irrational. Okay. Next sum, root 5 minus 3 is irrational number. We have to prove that this is a given number, root 5 minus 3, that we have to prove it is a rational number. Proof. Let us assume that root 5 minus 3 is rational. If we assume that as a rational, that is equal to a by b. We have to keep that is equal to a by b because it is in the form of rational. A and b are integers. B is not equal to 0. Or a and b are co-primes. Okay. Next, only root number, root 5, we have to keep left up. Then minus 3, take it to right side. A by b already there in the right side. They take this minus 3 right side, it becomes plus 3. Then simplify it. B is a LCM. I have to cross multiply 3 into B, 3B, A plus 3B by B. By adding this, we will get A plus 3B by B. By equation, it is equation 1. Since 3A and B, all the numbers what are there in this fraction are all integers. Integers are there in the form of fraction, that means that is a rational number. If this is a rational number, then is equal to that number root 5 is there, no? Left side root 5. Between is equal to is there. Therefore, these two are equal to each other. If it is rational, then we can say this is also rational. Root 5 is also rational. If this is a rational, and so root 5 is rational. But we know that WKT means we know that root 5 is not rational. From our previous knowledge, we know that root 5 is not a rational. Here, according to this equation, we proved this is rational. Root 5 is rational. But we know that root 5 is not a rational. We are saying both. It is rational, it is not rational. We proved it here. It is a rational. But we know that from previous knowledge, root 5 is not a rational. This means it leads to contradiction. Therefore, our assumption wrong. Because in starting, what we assumed? This root 5 minus 3 is a rational. But now our assumption became wrong because our proving and what we know that both leads to contradiction. Our assumption became wrong. Therefore, given number root 5 minus 3 is irrational. Okay. What we wrote here, these steps, these sentences, you have to write correctly. It's very easy. What is the irrational number or root number? That you have to keep one side, another remaining part, everything you have to take a right side and make it, it is one rational number. Make a fraction, then that is a rational number. If one side is rational, then that left side is also will be rational number. Here in equation 1 we will prove it is a rational number. Then what we have to write? We know that root 5 is not a rational by our previous knowledge. Like this we have to make a contradiction. After making a contradiction, we have to write what we assumed in the starting, that became wrong. Therefore, given number is irrational. Okay. It is very important method. It will come definitely. You practice yourself some more sums like this only. Then you can do this sum. Okay. Next, one more sum like this only. 2 plus root 3 is irrational number. I have to prove the given number 2 plus root 3 is irrational number. To prove this, I have to assume. Let us assume that 2 plus root 3 is rational. If it is rational, that is equal to, I have to write A by B. A and B are the integers and B is not equal to 0. Then A and B are co-primes. Okay. Then root 3 is equal to A by B. This plus 2 I have to take right side. It become minus 2. Only root part I have to keep left, remaining everything take right side. Plus 2 take right side, it become minus 2. Then I have to simplify this. I have to take a LCM. B is the LCM and cross multiply. A will be as it is. By multiplying B, this become minus 2B. A minus 2B by B. This is a rational number. Since 2, A and B are integers. In this fraction, what numbers are there? A, B and 2. That all the numbers are integers. So, this is a rational. If this is a rational, then left side, what number is there? Root 3. That is also rational. Right side is rational means what left side is there? That is also rational. Therefore, root 3 is rational. But this leads to contradiction because we know that here we proved it is a rational. Root 3 is a rational. But we know that from our previous knowledge, we know that root 3 is not a rational. This leads to contradiction to our assumption. Our assumption became wrong. What we assumed in the starting, that is a given number is a rational. But here we proved it is not a rational. Therefore, 2 plus root 3 is irrational. Students, take the sums for the drill. Same sums, only numbers are different. Method same. In that method only you do this, practice these sums. First one is 3 minus root 2. Then second one is 5 minus root 3. What I did, that also practice properly and do these two yourself. Next we will do prove that root 5 is a irrational number. Here they given a single root. In previous sum we did 2 number sum. Here if only one root is given, how to prove it? It is an irrational number. Okay, see here. First I have to assume that the given number, let us assume that root 5 is rational. To prove irrational, first we have to assume that it is a rational. There exist integers p and q such that root 5 is equal to p by q, where p and q are co-prime to each other. Therefore, root 5 into q, that denominator q, have to take this side, is equal to p. Right side p by q have to take first, then q transfer to left side, that become root 5 into q. Squaring on both sides. Have to make a square on both sides. This root goes by making square. It become only 5 and q square. By squaring this part, this whole thing, root goes and it become 5. This q square. And then total 5q square. Right side by making square, it become p square. This means 5 divides p square. If you transfer 5 this side, right side, that goes down. That means 5 divides p square. If 5 divides p square, that means 5 divides p also. Okay. Let p is equal to 5k, where k is an integer. Divides a, instead of in this equation only, I have to replace p by 5p. Write this 5q square as it is. Then in place of p, I have to take as 5p whole square as it is. By making square, this become 5 become 25, p become p square, 25 square. Then this 5 transfer this side. It comes to denominator. Q square is equal to 25 by 5 p square. By transferring to right side, 5 comes to denominator. It become 25 by 5. P square will be as it is. Q square remains as it is in the left. Then simplify this. 5 ones are 5, 5. Then 5 p square. Left side q square remains as it is. By simplifying this, it becomes 5p square. Again, this 5 remaining coefficient of p square 5 remains now. That 5 transfer to this side, that goes down. That means q square is divisible by 5. 5 divides q square. Q square is divisible by 5. Then q is also divisible by 5. This is equation 2. This means from 1 and 2, we can conclude that 5 is a common factor for both A and B, or P and Q. Here we took P and Q. Therefore, 5 is a common factor for P and Q. But this leads to contradiction. Our supposition, our assumption that A and B are co-primes, or P and Q are co-primes. What we assumed in starting, that became wrong. Hence, root 5 is an irrational number. Okay. What we have to prove here? First, we have to prove P is divided by 5. Then again Q is also divided by 5. That means P and Q both are divided by the same factor 5. That means P and Q are not a co-primes. Co-prime means those number which should not have a common factor are called as co-primes. But here in starting we assume that P and Q are A and B, whatever you can take, that are co-primes. But here we proved those are not a co-primes. Means both are having a common factor. 5 is a common factor for both. Therefore, root 5 is not a rational, it is irrational. Okay? Students, in next sum, they are given 2 roots. In previous sum, we did 1 root and one other number, 1 integer, and only single root. Then here they given 2 also root numbers. If they will give like this number, how to prove it is a irrational number? See here. Here given sum is prove that root 5, root 3 is an irrational number. Solution. Let us assume that root 5 plus root 3 is a rational number. It is rational means I have to write that is equal to x by y. Any letters you can take, a by b, p by q. Here I took x by y, where x and y are integers, y is not equal to 0. Then 1 root I have to take to right side. Any 1 root you can keep left on. I kept here root 5 and root 3, take it to left, right. That become x by y minus root 3. Then squaring on both sides. Root 5 whole square, in right side x by y minus root 3 whole square. By squaring this become root and square cancel, only 5 remains. In right side it is like a minus b whole square. According to formula a minus b whole square, I have to expand this. A square, a means x by y, b means root 3. A square means x by y whole square, plus b square means root 3 whole square, minus 2 into a into b. A means first term, b means second term. What is the first term here? X by y. Second term is root 3. Then it becomes 2 into x by y into root 3 according to a minus b whole square formula. Understood now? This is according to a minus b whole square formula. We expanded this. Now I have to simplify. A square means here inside a by b is there. X by y both up and down I have to make it square. It becomes x square by y square plus root 3 whole square, square and root cancel each other, only 3 remains. Minus 2 as it is, I have to multiply these two. 2 into root 3, 2 root 3 x by y. 2 root 3 x by y. Then I have to take this number plus 3 to left side. 5 minus 3. 5 minus 3 will be 2. Then x square by y square minus 2 root 3 x divided by y. From this I have to transfer root 3, I have to separate only integer one side. That is our intention. Here we have to show any one irrational number, root number one side, other all the rational number one side. That's why we have to separate this part one side. Because of that intention, I have to transfer to left side this part. 2 root 3 x divided by y. This whole part I took one side. Then this 2 y square transfer to right side. It become this transfer to towards 2 y square into 2 2y square minus 2y square. X square will be as it is, x square minus, first to transfer this side, it become 2y square. Again this take left side, this 2y square to right side, it become x square minus 2y square. X square will be in right side only. This whole part take left side, this minus become plus, then take this to y square to here, then these two multiply 2y square, again 2y square, take right side, it become minus. This part take left side and 2 take right side. Then it becomes x square minus 2 divided by y square. X square by y square minus 2. That we have to simplify. Y square is become a LCM. By taking y square as LCM, I have to multiply to 2. Then x square minus 2y square divided by y square. Then this x transfer to right side. X, y both side in the denominator. Here y square, here y is there, no? 1y, here also 1y, have to cancel each other. Only remaining one time y. This y and in this 1y cancel each other. Then only 1y remains in the denominator, and this x take to right side, that goes down. Then whole denominator become xy. Here only 2 root 3 remains. Okay. Then again we have to take 2 towards right side. Then only root 3 remains. Now what we was proving, no, that we got it. Root 3 in the left side, remaining everything in the right side. It become a rational number. Now it is rational means this root 3 is also rational. But we know that it is not a rational. Like previous sum, I have to write according to this equation. This is a rational means this root 3 is also rational. But we know that root 3 is not a rational. Therefore, given number root 5 plus root 3 is irrational. First root 3 is irrational. Then with that root 3 plus root 5 is irrational. Like this, I have to prove if two roots are given, then how to prove it? It is a irrational. Understood, no? One side I have to make it a rational number. Another side only I have to keep one irrational number or one root part. After that it is same 2-3 sentence I have to write how we did like this. Okay. Students, here also two roots are given. Prove that root 2 plus root 3 is an irrational number. Here I did simple way. In previous sum also we did 2 roots, no? But that type if we'll take rational number, what we'll take here, that in the fraction in the form of p by q means it will become little lengthy. I took here only a. See here, we'll start, you can understand. Let us assume root 2 and root 3. Here also 2 roots are given. Prove that root 2 plus root 3 is an irrational number. Here first take a solution. Let us assume that root 2 plus root 3 a rational number. This implies root 2 plus root 3 is equal to a. Here a is a rational number. I took here instead of p by q a. Rational number in the form of fraction, it will be little lengthy. In previous sum we did x by y. This is equal to, given 2 roots is equal to, I took x by y, that become little lengthy now. Here I took only a. A means that is a rational number. If we take like this, it become short. Okay. In these 2 roots, one root I have to take right side. Root 3 keep left only. Root 2 take right side. It become minus root 2. A minus root 2. Then square on both sides. Root 3 whole square. That root and square cancel. Only 3 remains in the left. And right side a minus root 2 whole square. Then here we have to take a formula a minus b whole square. Here root and square cancel, only 3 remains. This become a minus b whole square means a square plus b square minus 2ab. Here a means a only there, b means root 2. First term is a, second term is root 2. A square plus root 2 whole square. A square means a square according to formula. B square means root 2 whole square minus 2 into a into root 2. Root 2 is a second term. A is a first term. 2 into first term into second term. This is according to formula. I expanded. Then we have to simplify. This implies a square as it is, and root and square cancel. This become only 2. Then 2a minus minus 2a into root 2. Then this part, root part, I have to take left. This integer I have to take right. 3 take right side. It become plus 3 become minus 3. This minus part become plus. Plus 2a root 2. Here this a square and this become only 2, no? 2, then 3 minus 3. 2 minus 3 become 1. A square minus 1. Then this 2a take right side. Coefficient only keep left side. Root 2. 2a take to right side. It goes down. Then a square minus 1 divided by 2a. A square minus 1 divided by 2a. This is a rational number. If this is a rational number, then root 2 is also rational number. From this, root 2 is rational number. 2 is a rational number because this right side part, a square minus 1 by 2a, is rational number. But we know that root 2 is not a rational, it is irrational. This leads to contradiction. Hence, our assumption that root 2 plus root 3 is rational is wrong. What we made a assumption in starting, root 2 plus root 3 is rational. That is wrong. Therefore, given number root 2 plus root 3 is an irrational number. Next, we'll do express the number as a product of its prime factors. Okay. The given number is 7650. To write the factors of its to write the prime factors of given number, I have to factorize this. 7650 divided by 2. Any even number start divide by 2. First last 0 is there or even number is there, that is divided by 2. By dividing 2, 2 3s are 6 and 1 remains, it becomes 16. 2 8s are 16. Then 2 2s are 4. 5 is not going by 2. Nearest number is 4. 2 2s are 4. Then 1 remains here now. Add 0, it becomes 10. 2 5s are 10. It becomes half of this, 3825. Again divided by 5. If it is 0 or 5 in last, then we have to divide by 5. Only one digit will take, it is not going by 5. Take 2 digit. It becomes 38. 38 divided by 5, 5 7s are 35. 35 subtracting 38, 3 remains. That 3 added by 2, 3 and 2 become 32. Here 3, here 2. 32 divided by 5, 5 6 are 30. Again 2 remains. Then 2 here, next 5, 25. 5 5s are 25. It became 765. Again at the end, at unit place 5 is there, no? Divide by 5. 5 1s are 5. In 7 subtract 5, 2 remains. Add this 6, it becomes 26. 26 divided by 5, 5 5s are 25. In 26 subtract 25, 1 remains. That 1 in this place and 5 next unit place, it becomes 50. And 5 3s are 50. This became 153. Then we can divide this number by 3. It's not going by 5. If it is 5 or 0 in the unit place, I have to try by 5. It is not going by 5 means I have to try by 3. First digit 1, we can't divide single digit. Then add next digit, it 15. Then 3 5s are 50 and 3 1s are 3. We got 51. This 51 again we can divide by 3. 3 1s are 3. In 5 subtract 3, 2 remains. Then here 2, here 1 means 21. 3 words are 21, 3 7s. We got last number 17. That is factors of prime factors of this given number. Given number is 7650. Therefore, that is equal to all the factors that we have to write. 2 into 3 into 3 into 5 into 5 into 17. Or we can write 2 into 3 into 3, we can make it 3 square. And 5 into 5, we can make it 5 square into 17. 2 into 3 square into 5 square into 17 are the prime factors of given number. It's so simple, very easy. Then they will ask this type of factorization or write in the form of prime factors. You have to do it. It is very easy. Practice it. Okay. Next given number is 8211. This is not a even number. Therefore, we can't start by 2. That's why I have to try by next number, that is 3. 3 2s are 6. 6 subtract in 8, remaining 2. That 2, next number add 2, then it becomes 22. 3 7s are 21. In 22 subtract 21, 1 remains. Then next number is 1. 1 1 11. 3 3s are 9. In 11 subtract 9, 2 remains. Then last number is 1. Here 2 remains. Here 1. 21. Again 3 sevens are 21. Next, this number is not even. We can't divide by 2. It is not divided by 3. Last 0 or 5 is there. We can try by 5. Here that is also not there. Then we have to try by 7. By 7 it is dividing. 3 is 7. 3 is a 21. Then 6 remains. In 27 subtract 21, 6 remains. Then add next number, it becomes 63. 7 nines are 63. Then last number is 7. 7 ones are 7. Next, this is not dividing by 3 or 7, any other 11. We can't divide. We have to try other number, next number, other prime factors. We have to take and try. Lastly, we can divide by 17. I have to do trial and error method here because it is not a even number. We can't divide by 2, we can't divide by 3, we can't divide by 5. Last 0 or 5 is not there. Like that, by trying by 17, we can divide it. So 2s are 34. Then 5 remains here. Then 51. 17 3s are 51. This 23 is also prime number. Next, we can't continue. These are the factors. These are the prime factors of this number. Therefore, 8211 is equal to 3 into 7 into 17 into 23. These are the prime factors of this number. Next number is 25,025. Last, write this number. Then last 5 is there. If last digit is 5 or 0, we can divide by 5 directly. Then 5 5s are 25, 0 as it is. This 2 also we can't divide. Again we have to keep 0. Then it became 25. 5 5s are 25. We got 5005. Then again divide by 5. 5 ones are 5, 0 as it is, 0 as it is. Again 5 ones are 5. Next, we have to divide by 7. 7 ones are 7. In 10, 7 subtract means 3 remains. It becomes 30. 7 4s are 28. In 30, subtract 28, 2 remains. Then add next number. It is 1, 21. 2 here and 1 here, 21. 7 3s are 21. Again, divide by 11. 11 ones are 11. 3 remains. Last digit 3 is there. 3 and 3, 33. 11 3s are 33. We got 13 here. That is also prime number. Then all these factors are prime factors of this given number. Therefore, 25,025 is equal to 5 into 5, 5 square, 7 into 7 into 11 into 30. These are the prime factors. Next is very simple number 120 divided by 2. 2 6 are 6, 0 as it is, and again divided by 2. That 2 3s are 6, 0 as it is. Again divided by 2. 2 ones are, then 1 remains, add 0, it becomes 10. 2 5s are, then it is not dividing by 2. I have to take 3 here, divide by 3. 3 5s are 15 and 5 ones are 5. These are the factors, prime factors of this given number 120. 120 is equal to 2 into 2, 2 square, 2 square into 2, 3 times 2, we can write 2 cube into 3 into 5. These are the factors. Like this, you can factorize and find the prime factors. It is very easy. We can get marks by this method easily. Practice properly. Okay? Find HCF of the given two numbers. Students, next we have to find the HCF of the given two numbers. Here given numbers are 16 and 80. In these two given number, I have to take bigger number as a dividend and smaller number as a divisor. Here 80 divided by 16, 16 5s are 80. We will get the 0 remainder. 16 5s are 80, 80 and 80 subtract. By simplifying we will get the 0 remainder. Therefore, this 16 is the HCF of both the given number, in which remainder 0, that divisor will be there, no? That is considered as the HCF of both the number. Therefore, in this sum 16 and 80, HCF is 16. Here given two numbers are 867 and 255. Here bigger number is 867. I have to take it as a dividend, and this 255 take it as a divisor. Divide 255 3s are 3 into 5 15. 3 5s are 15. 1 carry again. 3 5s are 15 plus 1 16. 1 carry again. 3 into 2 6 plus 1 7. Total 3 into 255 we got 765. Subtract in 867 we will get 102. This remainder I have to take it as a divisor, and in previous step what divisor was there 256, that we have to make it as a dividend. Divide by 102. 102 2s are 204. 2 into 2 4, 0 as it is. 2 into 1 2. Subtract 204 in 255 will get. Okay. According to division lemma, I have to write this division like a dividend, take left side. This is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. Next, for this step, again here dividend is 256, 255, that is equal to divisor is 102 into quotient is 2 plus remainder is 51. Okay. Next step, this remainder 51 I have to take as a divisor, and this divisor 102 I have to take as a dividend. 51 2s are 102. 2 1s are 2, 2 5s are 10. Subtract, we will get 0. In which step 0 remainder will get? In that step, what is the divisor? That is become the HCF of given two numbers. For this step, I have to write division lemma. Dividend 102 is equal to divisor 51 into quotient 2 plus 0 remainder. When we will get 0 remainder, there what is the divisor? That is the HCF of the given number. Therefore, for these two number, HCF is 51. Next sum, find the HCF of the given number, given two numbers 1353 and 861. In these two given number, I have to take big number as a dividend and small number as a divisor. 861 1s are 861. Then simplify this, subtract, we will get 492. By subtracting 861 in this number, we will get 492. This step I have to write as a division lemma 1353. 1353 is a dividend, that is equal to divisor 861 into quotient 1 plus remainder 492. Okay. Next step, here what was the divisor, that we have to take here as a dividend. and what is the remainder in the previous step, that we have to take as a divisor. Then 392 ones are 392, 492 ones are 492, and then we have to subtract 492 in 861, we will get 369. That we have to write dividend is equal to divisor into quotient plus remainder. Okay. Next, in a previous step, what divisor was there, that we have to make it here dividend, and remainder have to take it as a divisor. 369 ones are, then subtract 369 in 492, we will get 123. This division we have to write in the form of division lemma. Dividend is equal to divisor into quotient plus remainder. Okay. Next, here what is the remainder, we have to take it as a divisor, and what is the divisor, that we have to take it as a dividend. Divide it, 223 3s are 369. 3 into 3 9, 3 into 2 6, 3 into 1 3. Then subtract this, we will get 0. Where we will get a 0, in which step we will get a 0, in that step what was the divisor is there, that divisor is become the HCF of the given 2 number. This steps are division lemma, I have to write like this. 369 is a dividend, that is equal to divisor is a 123 into quotient is a 3 plus remainder is 0. Here we got 0 remainder, therefore what is the divisor here, that is the HCF of the given 2 number. Understood? Practice like this other sums also, how to find the HCF of the given 2 number. That is very easy. More extra sums, practice it yourself, you can do. Okay. Then practice all the sums from this chapter. Then subscribe my channel and like it.